Hi, this is Professor Pradyot of Leadib Academy, and we are looking into the video solution of IBDP Chemistry HL Paper 1, May 2019. Okay, and I have provided you the reference number, okay, that which paper we are solving. As you people are aware of that Leadib Academy, okay, we are providing the courses for the interesting subjects like chemistry, physics, math, okay, and you can always go to the link and get those courses, okay, so that you will get the much detailed idea, deeper understanding of the subjects. And besides that, we can provide you one-to-one online coaching, so to improve your grades better. So let's start looking into this question number 11. Okay, so it is being asked, which combination corresponds to strong metallic bond? Okay. So first of all, let's understand what is mean by a metallic bond. Okay, so let's look into this. What is metallic bond? So you can clearly see that there is a lattice of metal ions. Okay, it could be iron, copper, nickel, okay, anything, and surrounded by electrons, which are free electrons. Okay, we can say that these are free electrons. So what you can visualize, that metal ions floating in sea of electrons, sea of free electrons. And we are already aware of that because of these free electrons, metals are excellent or good conductors of electricity, heat, etc. So so now let's understand how this bond can be stronger. Now, what is this bond? So understand that if you take any positive lattice, okay, or ion of metal, which is surrounded by these electrons. Okay, I'm just showing only 4 for your easy understanding. And obviously, there is going to be attraction. Okay, there's going to be force of attraction. Now, if this charge is higher, now when this attraction can be higher? Okay, simple. Okay, very, very simple. This attraction will be higher if this charge itself is high. Charge is high, obviously. And second thing, if this charge is distributed over a smaller volume, that means we are talking about not only the charge, but charge density. It simply means that this charge, because we can visualize this metallic ion as a sphere, okay, and if we know that this, what is going to be the volume of this, it is going to be 4/3 pi r cube. So if this r is small, where r is the ionic radius, if this radius is small, that means this volume is going to be smaller, and same charge is getting distributed over a smaller volume, okay, or a smaller surface area, whatever you call it, then the density of that charge is going to be higher. So obviously, because of this, this bond is going to be much stronger. Okay, that's the reason. So it simply means that which option is correct. So large charge, yes, absolutely, and small radius of ion. Okay, very, very simple. So the correct option is B. Extremely simple thing. So what we have learned that, and basically, by the way, if you are learned in physics, this is coming from the Coulomb's law. Okay, so if you are interested, okay, you can study the Coulomb's law. There is a course available on physics from Leadib Academy. So you can always get those details. But simple thing, just to keep the thing simple, charge has to be higher on that ion, okay, sorry, on ion, and the charge density, that means in short, the radius has to be smaller, ionic radius, okay, so that the metallic bond will be stronger. Hope this is quite clear and interesting. Okay, we are looking into this interesting question, question number 12. Which species has delocalized electron? So what do you mean by delocalize? Okay, let's try and understand what do you mean by delocalize. So delocalized electrons means electrons which are not localized, that means they are not permanent or stationed at one specific atom. They are not permanently there. That means they are moving, okay, and that is why we talk about the concept of resonance. It simply means that electrons are keep on moving between the different atoms, okay. So basically, in case of this, what we talk about, the movement of, if you recollect, okay, we talk about the movement of lone pairs and pi electrons. These are the main two things which keep on moving, okay. So let's understand which radical or molecule falls under this. Straightforward, OH minus, no way, okay. Oxygen and hydrogen, there is nothing is there, okay, so this is out. H2CO, it's not there. CO2, it is not there. Yes, carbonate radical, okay. Carbonate radical, let's see those resonating structures. Okay, let me explain this, what is mean by this, okay. So these are the carbonate radicals. So what is happening in this case, you can clearly see, okay, you can clearly see, let me put it with the different color, okay. So what do you get from this? It's simple that there is one double bond, okay. So if we number 1, 2 and 3, so in this structure the double bond is between carbon and oxygen number 1, okay. I'm just mentioning for simplicity, while in this and between oxygen number 2 and 3 there's a single bond. Now in this case 1, 2, 3, in this structure the double bond is between carbon and oxygen number 2, and in the third one oxygen and number 3, okay. So what is happening, that basically there is a movement, okay. These are curly arrows, okay. These are the curly arrow, that means they are indicating that whatever are these double bond, that means pi electrons, they are getting shifted from pi, okay, that double bond to one oxygen, okay, specific atom. That's all, okay. And that is what, how the movement is taking place. So in this example, that pi electrons which have got shifted, and that's why we are seeing this in the orange color, and simultaneously this lone pair is coming as a double bond, okay. And that's why you are seeing this simple. That means there is a clear cut movement of pi electrons and lone pairs, or it can be only pi electron, depends, okay. But what is important, that there is a continuous movement, okay. So if you ask which structure is correct, okay, so the correct structure, okay, so these are called resonance structures. Resonance structures, and the correct structure is this. oxygen, oxygen, and oxygen. And I will say, for your information, the correct structure is like this. Okay, that means, okay, between 1, 2, and 3, there is neither single bond nor double bond. Okay, it is in between these two. Okay, so this is what is the structure of this. Okay, simple. And therefore, the correct option is D. Okay, so which concept we are applying? The concept of resonance. So you should get conversant of drawing the resonating structures. Okay, and please do refer to our course, because in course we are having a separate topic, okay, explaining this in detail. Okay, so you can keep on referring to that. Okay, so let's look into the next question. Okay, let's look into this interesting question number 13. How many carbon atoms are with sp3, sp2, and sp hybridized? Okay, so what is the concept? Okay, you can do it like a very, very simple technique. If there is a triple bond carbon, okay, triple bond carbon, it simply means sp double bond sp2 and single bond carbon sp3. Simple. So let's start counting it. It is as simple as that. This is basically, this carbon is triple bonded, so it is sp. Even this carbon is sp. Okay, now please, this one, that next one, it is basically a single, okay, single bonded, so it means it is sp3. This is also a single bonded, so this is sp3. This is clearly double bonded, so sp2, and this is sp3, single bonded. Okay, so it is how many? This one we can clearly see sp3, there are 3. Okay, 1, 2, and 3. So that is correct. So there are various options. How many sp2? sp2, there's only 1, so that means 3, 1, and 2. So that means the correct option is A. Okay, very, very simple. So how to find out? Very, very simple. Just look at the double bond, triple bond, or single bond, and dependent on that, you can easily find out. Okay, it's like a cakewalk. Okay, you can easily find out this. Very, very simple. Okay, let's look into this question number 14. Okay, when equal masses of X and Y absorb the same amount of energy, the temperature rise by 5 degree and 10 degree respectively, which is correct. Okay, let's understand. Very, very simple. So what have been given to us? Equal masses. So let's assume that their mass is m. Okay, what else? Delta T, that is given for this. So assume delta T for this is 5 degree. Delta T for this is 10 degree. And assume this object, okay, it is having a specific heat of Cx, and this has Cy. Okay, and absorb the same amount of energy. So what is mean by this? Okay, we know that Q, that is a heat absorbed, is equal to mc delta T. So what we can say for the object number 1 and object number 2, Q is same. So what we can say, mcx delta T in this case is 5 degree is equal to mcy into 10. M goes out and we can conclude Cx is equal to 2Cy. Okay, this is the conclusion. Simple. Okay, so it simply means that the specific heat of X, okay, is twice that of Y. Simple. Very, very straightforward. This is the correct option. Option E. Extremely simple, formula based. We can, so just to give you the perspective, what we can say that from this equation, okay, if Q and M is same, we can say specific heat is inversely proportional to temperature rise. Okay, this is the conclusion what we can say. It simply means that lower the temperature rise, higher is the specific heat. That understanding has to be clear. The substance which is having a higher specific heat, the temperature rise would be lower. Okay, it's very, very important property because you are seeing so many examples like why water. Okay, water is a very, very important substance, okay, naturally occurring. Why? Because it is having a very high specific heat. And that's why we see so many interesting phenomena. Why the temperature of the ocean doesn't change substantially. Okay? Even though the ambient temperature may be 50 degree, still the ocean temperature would be around 30, 32. Okay? Because of the high specific heat of the water. Otherwise, it would have been totally different. Okay, ball game altogether. So very interesting concept. Okay. Okay, let's see the question number 15. What is the enthalpy change of reaction for the following equation? So what we are going to apply? Simple, Hess law. Okay. So what Hess law states? Okay. That it simply states that if reaction is taking in a multiple steps or enthalpy change for one of the reaction cannot be calculated directly, then you can use several reactions. You can take the help of several reactions and you can find out the enthalpy change. And that is more appropriate for this. So what we have been asked to calculate is this: C2H4 plus H2 giving you C2H6. So what do we call this? This we can call it as hydrogenation, okay, of basically the ethene, or we can say reduction of alkene or ethene. Okay, anyways, so this is what is the target. So how to calculate now? We have been given basically these three combustion reactions. You are identified because we are burning in presence of oxygen. So what is important of this? That how we are using the combustion reactions enthalpy to calculate this enthalpy of this given reaction. This is what we have to understand, that combustion, and why we are calculating combustion reaction, because typically combustion reactions heat, okay, or enthalpy change can be easily calculated. We can burn and find out, but in this case it is a little bit challenging. Okay, so let's understand now. So now how to look into this? So first of all, let's look into this reaction number 1, 2 and 3. So our desirable is ethene C2H4, and in this case it is on the left hand side only of the reaction, so we don't need to bother. So we will say that means it is available to us, so we will say X. Then comes the second reaction, C2H6. Oh, C2H6 is on the left hand side in the 2. while in the desired one, it is on the right hand side. This is what we are targeting. Okay, so it means that we have to change the sign of this enthalpy. That means we will say minus y. Now coming to the next, this one, that is a hydrogen. Oh, in the third reaction, we are finding it on the left hand side only. And for our target reaction also, it is on the left hand side. So we don't need to change. We will keep it as it is. That's all. This is our enthalpy of the reaction. X minus y plus z. Extremely simple. We are using basically the enthalpy of combustion of these three reactions to find out the enthalpy of the reaction. That's all. Okay, very, very simple application of the Hess's law. So in short, the correct option is D. Correct option is D. Very, very simple. Okay. Okay, let's look into the question number 16, which is correct for the reaction H2O gaseous to H2O liquid. So first of all, we should be analyzing what this reaction is saying. Okay, so basically it is simple. Water vapor are getting changed to water liquid. Okay, or liquid water. Water in liquid form. So what do we call this? This is the process we called as condensation. So what happens in condensation? There is a loss of heat. Okay, we need to cool it. Okay, when water vapors heat is taken out, okay, by cooling it, that means heat has to be removed. Okay, so we will get basically the condensed liquid. Okay, condensed vapor. Okay, that is basically nothing but a water condensation. So what is happening in this process? Delta H, that enthalpy, has to be removed. That means loss. Okay, so enthalpy has to decrease. Now let's talk about the entropy. What is the entropy? Entropy, please understand. Entropy means randomness. It indicates the randomness. So tell me now, out of vapors and liquid, which are more random? Simple, vapors are more random. Okay, in the vapor state, there is a more randomness. Molecules are spread like they are moving randomly in the vapor state or gaseous state. Okay, so from the higher entropy to the lower entropy. Okay, because liquid means it is a more orderly arrangement. So again, entropy is decreasing. Okay, so there is a clear-cut decrease. Okay, so in this case, entropy is also decreasing. So enthalpy is also decreasing as well as entropy is decreasing. Okay, enthalpy is decreasing because heat is being taken out. It is like a cooling of the vapors. And entropy is decreasing because randomness is getting reduced. In the liquid state, the molecules are more orderly as compared to gaseous. Okay, so the correct option is simple. It's D. Okay, option D. Very, very simple. Okay. Okay, let's look into this question number 17. Which reaction represents the standard enthalpy of atomization of bromine, Br2? Okay. So now here comes the interesting part that you should be very, very clear with the definition. So what I mean to say, definition of standard enthalpy of atomization. Okay, so what is that? This is the enthalpy change, okay, when 1 mole of gaseous atom is formed from an element under standard condition. Okay, so what is what should happen? Basically, we should get a gaseous atom from element under standard condition. This is very, very important to understand. Okay. So in this case, now let's start analyzing this. Let's say equation A. We are forming, okay, half Br2, okay, giving you Br. Okay. Absolutely, because bromine's standard condition is liquid, okay, and we are getting one gaseous atom. So this is perfect. Let's look into the other options, whether they are, why they are wrong. Because in this case, Br2 giving you 2 Br, no, because this is what is not expected, because we want to form only 1 mole. So that's the reason that it is wrong. In this case, Br2 liquid, and even we are forming liquid, not acceptable because it has to be gaseous. And here both are gaseous, again this is not acceptable. So the correct option is A. Simple. From standard conditions, element should be in the standard condition, okay, and it should be 1 mole also. Okay, we have to form 1 mole. That's the reason. Otherwise, even the option B would have been all right. Okay, but very, very important that we have to form 1 mole, that too gaseous atoms, and important that it should be from the standard condition. Okay, that's very, very important. Means, for example, if we would have been forming like this, gaseous, 2 Br gaseous, not acceptable, because bromine's standard condition is not gaseous. It is always in the liquid form. So you need to be careful. Okay, always important. So a lot of stress has to be given under the definitions. So I'll say, what are the 3 important aspects? 1 mole has to be formed, okay, then gaseous and standard conditions. So please try to understand these definitions very, very carefully, okay, so that you cannot go wrong. Otherwise, these options are typically overlapping, confusing, and that's why students find it really, really challenging. But if you stick to the basic definitions, you will not go wrong. Okay. So we have covered this extensively in our course, all these concepts to improve your grades. So please do subscribe to our course. So please do visit our website, Leadib Academy, okay, .com. Okay, let's look into this interesting question number 18. Which properties can be monitored to determine the rate of reaction? So we have been given this reaction. So can you understand what kind of a reaction we are talking about? Iron plus copper sulfate giving you copper and iron sulfate. This is basically nothing but a displacement reaction. Simple. Okay. Iron has displaced, if he has displaced copper from its solution. Okay. Simple. So in short, if you want to write down the reaction, it should be written like Fe, copper 2 plus, because it's in the form of ions, getting converted into copper, and Fe2 plus, okay, in the ionic form. Simple. Okay, so in this case, what we can say now, another characteristics, that here there is a solid state, again aqueous form, solid, and aqueous form. So there is no question of change in the volume. We cannot really measure the rate of this reaction by change in volume, because there is no real gaseous state. Because please remember that volume corresponds only to the gaseous state. If you look into this, the gas laws, like Boyle's law, Charles' law, we talk about the volume of the gas, because gases are compressible, not liquid and solids. Very, very important. So the volume cannot be changed. Okay. And even if it's changing, it is a negligible, insignificant for solid and liquids. So this is out. What about the change in the temperature? We cannot really comment, okay, because there is no information available at all. So there is no question of change in temperature. What about the change in color? Absolutely. Why? Simple. Because earlier there were copper ions, so they will have a distinct colors, and from there it is being changed to Fe2+. So there has to be a distinct change in the color. So solution will change the color. Please remember that color is due to the typical ions. Okay, and these are all metal ions, transition element ions. Okay, transition element ions. So they are changing in this displacement reaction. So obviously it will be due to the change in the color. Okay. So what else we can think of? Tell me, which one do you think is the correct one? Okay. Now understand that in this case, since there is no real option which states that this, so the volume is definitely, but there could be a change in the temperature. Okay, even though there is no clear cut information, okay, about the temperature change. So the only correct option is C. Okay, because definitely one is not there. So the options which are involving one are absolutely wrong. So that is one is out, B is out, and D is out. About the temperature, there is no real information which is available. So we'll assume, okay, so I'll say a little bit ambiguous, but the best option amongst all the options is C. Okay, we cannot really talk about the change in the temperature. But typically in any reaction, the temperature change occurs, okay, because there are very, very few reactions which are not exothermic nor endothermic. Okay, so typically there will be change, but at least this reaction or at least this equation doesn't specify that. So we'll assume, okay, that there will be some change and we can measure the rate of reaction. Okay, let's look into this interesting question from kinetics. Which conditions are required for the reaction between two molecules? So let's see what are the conditions. So let's say this is molecule A, let's say this is B. So first of all, they need to collide. Okay, so that obviously there has to be a collision. That's why we say collision theory. Okay, so the collision has to be there, no question. Then second part, they need to possess the energy. Okay, they need to, that collision has to have higher than activation energy. Okay, otherwise the collision will not be effective. Simple. So E has to be greater than EA. Okay, that is the activation energy. And another important aspect, that orientation needs to be proper. And that is very, very simple. That suppose these two molecules, okay, they are colliding but not in the proper direction. Let's say they are colliding, they are approaching like this, okay, and this is going to go like this. Then what will happen? There will not be any proper collision. Okay, there would be a collision, but it is like they are touching just each other, just tangential collision, so it won't be effective. So all these three conditions are necessary, okay, for reaction to occur between A and B. All three: collision theory, activation, it has to be, the molecule must be having an energy higher than activation energy or equal at least. Okay, that's the minimum energy it should possess, and it should have a proper orientation. So straightforward, the correct option is D. Simple. Simple. Option D. All three necessary conditions. Okay, so it's a good kind of a revision to understand the concept. Okay, very good, this one. Okay, let's look into this question number 20. Very interesting one. Which graph is obtained from a first order reaction? So first of all, understand what I mean by first order. First order reaction. It simply means mathematically dA by dt, this is called differential, is equal to K into A. Simple. Okay, this is how we define, because it's a first order, that means this is 1. If it would have been second, we would have put the power of 2 like that. Okay, simple. Now how to interpret this? What kind of a graph? Okay, so we can consider, since it has been plotted on the y-axis, because the rate, this is nothing but the rate of reaction. Okay, and this is concentration of the reactant. So you can clearly see this is on the y-axis. So I'll say y, and this is on the x-axis, and there is some constant. So it is like y is equal to mx. Straightforward. You are very much familiar with this form of equation. Can you guess this? Yes, it is absolutely. This is a straight line, but that is not adequate, because these two are straight line, important, passing through origin. Okay, passing through the origin. Important. So it straightway says that means the correct option is B. Okay, only in this case it is passing through the origin, while here it is a constant. Okay, the rate is constant, so that is not correct. That would have been the zero order reaction. Okay, very, very simple. So you should have some idea about the simple mathematics, okay, so that it is easy to deal with this such kind of a graphs and all. Okay, and please do subscribe to our courses, because these, in these courses we have explained these concepts in detail. Okay, so that you will understand much more. Okay, and you can improve your knowledge as well as the grades. Very important.